I should start by saying that this recording is post hoc. I gave this talk about a month ago now to the Philological Society in London, and I was asked to make this recording for those people who couldn't be here. Now, I expect the people who witnessed the original presentation will not be listening to this recording, but I would actually really like to thank them again for a very warm welcome and also very lively and I thought very constructive discussion afterwards that unfortunately can't be part of this recording, of course. But here goes without the discussion, but at least there's still the presentation. Well, I'd like to start from the idea that we can think of language as a phenomenon of the fourth kind. And to explain that, I have to start by explaining what phenomena of the first, second, and third kind are. Now, phenomena of the first kind, they're outcomes of non-intentional processes. And the pebbles that you see in the basket in the photograph in the bottom right corner below, they are outcomes of non-intentional processes, in this case processes of erosion by water. Phenomena of the second kind are outcomes of intentional processes, and what you may not have spotted yet is that the what appear to be pieces of or loaves of bread in the top right photograph are actually the same pebbles as in the photograph below, except they've been altered intentionally by human intervention. So they've been painted to look like bread. That's a phenomenon of the second kind, an outcome of an intentional process. That brings us to phenomena of the third kind. These are phenomena that are also the outcome of intentional processes, but the outcome as such is not particularly intentional. And we all know these phenomena there. The complex unintended patterns of behavior that emerge from simple sets of behavioral rules at the individual level. So for instance, pedestrians who are walking on a sidewalk may spontaneously divide into lanes, and this is not a kind of collective decision or an intended outcome. So none of the pedestrians actually wants for these lanes to emerge, even though they are, in this case, actually efficient. But the lanes emerge because pedestrians just seek out the quickest path to move ahead. The same behavior can also lead to non-adaptive patterns at the aggregate level. So if individual drivers all seek to pursue the quickest path to their goal, actually they may end up in a traffic jam. So these are phenomena of the third kind. We can extend this to complex patterns of behavior at the aggregate level that emerge from simple sets of rules at the individual level, even if the rules may not be implemented intentionally, as is probably the case in phenomena, as you can see here. So a shoal of fish taking on this characteristic vortex-like shape. So these shapes at the aggregate level, at the collective level, they emerge as a result of certain rules that the fish, probably unintentionally or below any level of awareness, of rules that these fish follow. There have been several attempts to model the kinds of rules that the fish might be adhering to, and this leads to different kinds of models, such as the metric distance model or the topological distance model, which attributes slightly different behavioral rules to each individual fish, but which result in the same kind of aggregate behavior, or in roughly the same kind of aggregate behavior. Okay, and now that brings us to language as a phenomenon of the fourth kind. What we have here is a situation where a simple set of behavioral rules at the individual level generates complex, unintended patterns at the aggregate level. Okay, so far nothing new, but what happens next is that individual agents internalize the complex aggregate pattern and come to treat it as a behavioral target. So the aggregate outcome that emerges from individual behavior becomes the target for new individual behavior. And this is what Barlow and Kemmer in their volume on the usage-based approach from 2000 have termed the feedback loop. Okay. The crucial point is that individuals learn their patterns of behavior from the aggregate, and the patterns of behavior that they've learned again feed into the aggregate, and this produces a kind of cycle. Now, in principle, individuals could derive different patterns of behavior from the same aggregate model. And so we can imagine that in a shoal of fish, there are some fish that adhere to the metric distance model and some fish that adhere to the topological distance model. And perhaps it wouldn't actually make any observable difference. Conceivably then, when we turn to speakers, we can think of them as we thought of those fish. We can imagine that perhaps there are some speakers who have internalized a generative grammar and some speakers who have internalized a construction grammar. And perhaps on the surface, you wouldn't immediately see the difference. This is particularly conceivable if the rules of grammar are not innate. So to the extent that grammar is not innate, it becomes likely or increasingly likely that speakers will infer somewhat different grammars. And it follows that particularly usage-based linguists have become very much interested in individual variation and have been trying to demonstrate, having increasingly turned to trying to demonstrate that people do in fact have different grammars. There's some dimensions of individual variation that have been well studied, some dimensions that have received more attention recently. For example, differences in language aptitude have been studied for a very long time now. Differences in cognitive styles have also been noticed. So, for example, there is literature arguing that you can recognize psychopaths from the way they use language, suggesting that different cognitive styles also lead to different styles of language use. More recently, work has also been done showing in the variationist paradigm differences in the participation in language change. And closely linked to this, also differences in language users' ability to monitor social variation. So it's been shown that some language users are better at keeping track of the social values of variables, of linguistic variables. And then closest to the core of grammar and phonology is work showing that people really do seem to have different grammatical and phonological representations. For instance, in the work by Eva Dabrowska. Now, all this attention to individual variation leads to a number of questions, and I've listed three questions here. The first is, how extensive and how deep is individual variation? Is the individual variation just a surface phenomenon that can be perhaps be explained away by an underlying universal cognitive architecture that just responds differently to different experiences, for example? Um, so how far does this go? Is this a surface phenomenon? Do people really have fundamentally different grammars, or is it just tiny, relatively trivial differences that exist between language users? Um, Second, suppose individual differences are relatively big, then we should begin to worry that perhaps aggregate data, as we commonly use it today, particularly in corpus linguistics, we should perhaps begin to worry that aggregate data is not a terribly reliable source of evidence. So, for example, consider a phenomenon like fuzziness. Suppose we have a population of speakers where 80% of speakers have unfuzzy, very rigid linguistic systems, whereas 20% of speakers have fuzzy systems. Well, if you look at the aggregate, then you will conclude that the language is fuzzy. Um, so that there is a certain risk of generalizing from aggregate data if individuals are perhaps fundamentally different. And that leads to the final question. If we're going to take into account individual variation, will we have to revise linguistic theory, or will it boil down to maybe just some fine-tuning, some tinkering, but no major overhaul? Okay, so that remains to be seen. So I will return to these questions at the end of this talk. However, um, I'll approach them from a particular case study, and that case study is on productivity, and so I'll turn to productivity now. Productivity has been defined by Bollinger in 1948 as the statistically determinable readiness with which an element enters into new combinations. And for instance, work by Johanna Bardal has built on this and has described different dimensions of productivity, such as generality, regularity, extensibility. But Bardal too has suggested that extensibility is really the core property of productivity, which sides with Bollinger's definition. So a morphological pattern, let's say, such as such as seen in the use of the th suffix in English to derive abstract nouns from adjectives, as in strong strength, long length, deep depth. That's a very unproductive pattern. It's not easily extensible. So you can't easily make new forms on this pattern. In contrast, an inflectional pattern like ed suffixation to form the past tense, as in want, wanted, look, looked, use, used, and so on, is highly productive. So it can be used um, on newly formed verbs, such as he had hectored and Achillized them all out of the pit. It tends to replace alternative past tense formation patterns, as we see in burn, burned instead of burnt, or hurt, hurted instead of hurt. If you give people nonce words, they will, and ask them to form the past tense, they will by default use ed suffixation again. So it's a very highly productive pattern. Okay. Productivity is usually measured by looking at hapexes, and the logic is that hapexes are one-off combinations in a corpus. So a hapex is something that in a corpus is attested only once. And in the case of morphologies, that's a complex form that's been coined only once. And the one-off character of hapexes is the best evidence that these particular complex forms, so the hapexes, have been assembled creatively as opposed to having been repeated from memory. It's the best evidence. It's not, yeah, it's not conclusive or definitive evidence, right? Of course. And particularly, there may be some problems with very large and very small corpora when using hapaxes as a measure of productivity, and I'll return to those problems later on. But by and large, it does make sense if we think of extensibility as the hallmark of productivity. It makes sense to use hapaxes as to measure productivity. So a pattern will be productive if it produces a lot of hapaxes, whereas a pattern that doesn't produce any hapaxes can probably be regarded as unproductive. What determines productivity? Well, here the literature has offered a lot of proposals. But the ones that I'll focus on here have to do with certain frequency effects, and particularly with the converse effects of type and token frequency. It is generally thought or agreed on in the literature that type frequency is expected to encourage productivity because it encourages schematization. Type frequency, a morphological pattern with a high type frequency, is a pattern that people will encounter in many different forms. And because there is large formal variation, people will be encouraged to abstract away from the specific tokens and infer a morphological schema, infer a more abstract pattern. And of course, because productivity requires that abstraction, type frequency is thought to encourage productivity and will correlate positively with productivity. On the other hand, token frequency is expected to correlate negatively with productivity. And that is the reason for that is that if a morphological pattern has few types and those few types have high token frequencies, then it's likely that people will simply remember the specific types and store them holistically and will not resort to the underlying morphological schema. They will not abstract a pattern, or they will not, in usage, will not activate that pattern very often. So high token frequency is likely to correlate negatively with productivity. There have been other determinants of productivity postulated in the literature, some with very good evidence, but in this talk I will focus on I will mainly focus on the role of type and token frequency. Okay. And so we can make the following prediction. Productivity will increase with type frequency, but other things being equal will decrease with token frequency. So for example, a pattern with many types and relatively few tokens will be highly productive, whereas a pattern with few types but many tokens will be low in productivity. Okay. Now, there is actually a lot of evidence supporting this hypothesis. It's not new, it's been well demonstrated, but typically relying on a particular source of evidence, and that source of evidence is comparison across morphological patterns. Where researchers have looked at the productivity of a particular pattern, its type frequency and its token frequency in aggregate corpus data, and then compared to other patterns with different type frequencies, different token frequencies, different measures of productivity. Now, I would like to try an alternative here, and that is compare productivity within a single morphological pattern and link it to type frequency and token frequency by looking at individual variation. So instead of looking across patterns, I will look across individuals and keep the pattern constant. And that has a number of advantages. First, it's a different source of evidence. So in principle, it can reinforce existing claims. Second advantage is that we can actually start looking at relatively subtle effects. So as long as you compare across morphological patterns, well, the differences between morphological patterns are very big, and people could argue, well, you're actually comparing apples and oranges. Whereas if we look at the same pattern but across individual uses, the differences will be quite small, and we can really begin to look for very small effects, which I think is interesting, which I'll try to convince you is interesting. Finally, there's also I think a theoretical reason for trying to do this. The explanations of productivity in terms of type and token frequency are essentially psychological explanations. And if an explanation is psychological, then you would expect it to have an individual level behavioral correlate. So you should be able to demonstrate it at the level of individuals. This is something that goes on in people's minds. So we should find a trace of it in their behavior, in their individual behavior. All right, so how am I going to do this? This is the setup. I'll select a productive pattern. I'll collect data on individual usage. I will measure productivity across individuals, and then take a number of measures that can be expected to be determinants of individual productivity. From the literature, you'd expect individual type frequency, individual token frequency as predictors, but there may also be some others, and I'll come to those. So this is the setup. I'll talk you through this in what follows, so each of these steps. First, the derivational patterns that I've selected are Lie derivation and Nuss derivation. Lie derivation as in certainly, grammatically, slowly. Nuss derivation as in flatness, correctness, openness. Both these patterns are highly productive, but they're not completely without constraints. So some you can think up forms that are perhaps a little bit awkward. I've listed some of those things like chillily, friendlily, smallly, blackly, publicness, Europeanness, youngness, rareness. So all of these, for various reasons, are perhaps a little bit unusual. In fact, I should say I've added question marks here, but they're all attested in my corpus. But still they are a little bit unusual. The fact that there are constraints on productivity also means, and there are soft constraints on productivity, so they're not hard constraints, that means that there is room for variation. People may be more or less productive, I'm sorry. Okay, then there is the corpus data. Ideally, I would be able to make use of a very large homogeneous corpus with unpolluted individual usage, ideally spontaneous usage. That ideal is not currently, well, there's just no data source that would meet that ideal standard. But I've used two data sources that at least come relatively close, and they're both deficient, but they're deficient in different ways. The first corpus that I've used is the New York Times annotated corpus, which is a very large corpus with many contributing individuals. So this is simply a collection of all the editions of the New York Times since or between 1987 and 2007. So it's 20 years of New York Times data. It's a very big corpus. Many contributing individuals, many of them contributing a lot of data. So in total, I could get 698 journalists there for whom I had at least 250,000 words of text, so on an individual basis. And I've also capped data collection at 250,000 words for reasons I'll explain below or later on. Now, there are some problems here. First of all, there is the possibility of editorial intervention, and editorial intervention may be severe. My personal hope is that the journalists that I've sampled are very seasoned journalists, so these are very experienced journalists. They're journalists who produced a lot of text. I expect that they know what their editor wants, and at the same time the editor works under time pressure, so may not have time to intervene substantially, although well, experience from the audience here indicated that editorial intervention may actually be rather severe in some cases. So yeah, there is a certain risk that these data are polluted. It's not purely individual or not representative of purely individual data. Another problem with the New York Times is that the data is actually quite heterogeneous. So the New York Times publishes editorials, news articles, sports reporting, obituaries. There is the New York Times Magazine. Okay, there's lots of different text categories there, and the problem is, of course, that journalists' production is not evenly spread across those categories. So journalists specialize in certain niches here. So variation that you find between journalists may not be due to individual differences, but to register differences, which is a problem. Okay, again, I'll return to that. Second corpus is the Hansard corpus, which contains proceedings from the British Houses of Parliament from 1803, if I'm not mistaken, up to 2005. Again, it's a very large corpus. I've sampled the period 1990 to 2005, so that's somewhat similar to the data I have for the New York Times. In contrast to the New York Times, this is a pretty homogeneous corpus, right? So these are parliamentary debates. It's a single genre. And it's a more tightly knit speech community where at least you assume that people are actually interacting and listening to one another and responding to one another. The main problem here is that there is a very complicated transmission history. So MPs prepare a text, perhaps they have a text prepared for them by others. That's very well possible. That text is then delivered in Parliament. Note is taken of the text is written down by note takers or scribes, and that then again is edited into a transcript of the parliamentary debate. So it would actually be good to have a better idea of practices here, but this is very difficult to work out. So we don't know to what extent, or we don't have a very clear picture, or at least I don't have that very clear picture of how much intervention there is in how much third-party intervention there is in this process. So again, the data may be polluted. On the positive side, again, there is a lot of data. So I've got, again, 250,000 words of text for 171 individual MPs, which is, again, a very substantial data set. Okay, within this dataset, I've retrieved all instances of Lee and Nuss, and I've manually removed false positives. It's a very big dataset, but of course, false positives could be removed at type level, not at token level. So this was still manageable. But so just to give an idea, for Lee derivation, I have in the New York Times data, 1.5 million tokens. So it's a very, very big data set. What you can also see is that there are a lot of types and also a lot of very low, very rare types, so types with very low frequency. So here you see the type counts for types with a frequency below 0.1 occurrences per million words. So it's a very, very low frequency. There's also a lot of hapaxes, as you can see in the table, both for Lee derivation and for Nuss derivation. Okay. Now, for the analysis. So our dependent variable is obviously productivity. Question is, how are we going to measure productivity? The usual approach is to, or very common approach is to take a hapexes to tokens ratio. Now, I haven't done that for the simple reason that token frequency is going to be an independent variable. So if I include it in the dependent variable, then of course there's going to be an effect, but not the effect that we're looking for. I think it's safe to do away with the hapexes tokens ratio because the hapexes tokens ratio is typically used to compare across morphological patterns that have very different token frequencies, and so it's used to correct for big differences in token frequencies. But here we're just comparing across the same two morphological patterns within individuals. So yeah, there is less need there to control for token frequency. Also, there is the choice of limiting the output of individuals to just 250,000 tokens of text, or 250,000 words of text, which means that all these individuals have had, you could say, the same opportunity to produce hapexes of Lie or Nuss forms. Okay, so I've taken the simplest possible measure, and that's hapexes, and I think that's all right. More tricky question is, are we going to measure hapexes at the individual or at the aggregate level? If we measure at the individual level, that would seem to make sense. I mean, we're looking at individual variation. We're paying tribute to the individual as as our unit of analysis. So it somehow makes sense to measure hapexes also at an individual level. The problem is, if you do that, you end up including high frequency types as hapexes. So for example, there's one member of parliament who produced effectiveness, competitiveness, illness, and willingness all as hapexes in her particular 250,000 words of text, of output. But when you look at effectiveness, competitiveness, illness, and willingness in the aggregate data, they're actually all four among the top 10 most frequent Nuss derivations in the corpus, which makes it very likely that this particular member of parliament, even though she didn't produce these forms very often, she heard them very often. So they would very likely have been stored in memory. So it's even though there are hapexes in her particular usage, it's not likely that she coined them productively. And so, yeah, they shouldn't contribute to her productivity measure. Right. The alternative is that we look at that we count hapexes at the aggregate level, and that would mean that a hapex is defined as a complex form that occurs only once in the whole aggregate dataset. The problem there is that it will tend to favor bizarre and playful and near ungrammatical formations such as yawningly, nutriently, fertilely, Xavierness, horsiness, carnivorousness. Of course, if you want to measure productivity, these should be there, but they shouldn't be the only forms there. So these are conspicuously creative formations, playful, a little bit bizarre, and that's not just what productivity is all about. Productivity is really about people's ability or readiness to extend a pattern to a new linguistic context, whether that is creative or playful or unusual or not. So productivity is really about people's ability to move beyond the combinations that they have stored. That's not the same thing as their linguistic playfulness, right? So playfulness is, of course, a part of that ability, but it's not. That ability is not should not be reduced to playfulness or linguistic creativity. So I've come up with a compromise, and I've defined hapexes as types that are produced by an individual only once and with a frequency below 0.01 occurrences per million words in the aggregate data set. So that means a hapex is defined at the individual level as occurring once in an individual dataset, but also at the aggregate level as being extremely low frequency item in the aggregate dataset. Okay. On to the independent variables. First, there's type frequency, and that's simply all the types that are there in an individual's usage. Token frequency, same thing, all the tokens found in an individual's usage. Then there is another independent variable that I will refer to as main desk. Remember what I said about the New York Times corpus? It's a very heterogeneous data set, and what I've tried to do is come to come to grips to some extent with this internal heterogeneity by exploiting the information that's in the New York Times about the desk under which an article was published. So the New York Times has a number of desks. For instance, it has a metropolitan desk, it has a sports desk, it has a culture and lifestyle desk, and so on. And journalists contribute to these desks. And the desk says something. It's not the same thing as register, but it does say something about register. So news, which comprises the metropolitan desk and the national desk and the international desks. So this is all news reportage. Here you get articles that try to strive towards a disengaged style. So it's objective reporting. There is little subjectivity, little reference to the journalist. So you get this relatively objective reporting, in contrast to, for instance, culture and lifestyle. So I've defined a number of idealized desks: news, sports, finance, culture and lifestyle, and other. And then I've assigned each individual author to a particular desk, and that's the desk to which they contribute more than half of their written output. Okay, it's not ideal. It's still a little bit, so the author's output is still internally heterogeneous, but at least they are assigned to the desks they predominantly contribute to. Okay, and that's going to give us some handle on possible register variation in the New York Times corpus. As I said, it's not perfect, but it's something. Okay. Then there is a fourth independent variable that I introduced, and that's lexical diversity. And the logic here is that, well, we know that some people have rich vocabularies and some people have poorer vocabularies. And well, it's not impossible that people with rich vocabularies will find it easier to produce more diverse morphologically complex forms because they have more bases to form morphologically complex forms from. So that might feed into productivity, conceivably. Okay, now lexical diversity was measured as the average number of word types per batch of 1,000 words. So I just counted all the word types for every batch of 1,000, automatically, obviously, for every batch of 1,000 words, and then took the average. Okay, so yeah, you could ask why not just count all the words in the whole 250, sorry, all the word types in the 250,000 words of each individual. The problem is that there's quite a few spelling errors, and this approach gives less prominence to spelling errors. So spelling errors will weigh less heavily in the resultant measure. Okay. And then finally, there is an independent variable that I've called general productivity, and this stems from an observation when I was first exploring the data, and that's that individual productivity scores correlate across Lie and Nuss derivation. So people who scored high on productivity for Lie also tended to score high for productivity on Nuss. And that correlation is pretty strong. So there's a correlation coefficient of 0.82 in the New York Times data, and there's a correlation of 0.5 in the Hansard corpus data, which in both cases is fairly high. So we can ask, perhaps, is there something such as an individual propensity for more or less productive usage? So at this point, we don't know. So that correlation is there. It may be due to, for example, it may be due to factors that are shared across the two patterns. So for instance, register variation, or it may be due to lexical diversity, but it may be also just an individual property. And to test for that, this has been included in the analysis. So what I've done then is I've created 4 multiple linear regression models, one per derivational pattern, one per corpus, followed a bidirectional variable selection procedure. I've standardized the variables, and I've ended up with 4 models. All 4 are highly significant, with relatively good adjusted R-square values, which I've reported here for the 4 models. So they're pretty good. I think, so I'm not going to go into this, but they're probably a little bit exaggerated for the New York Times data. But even for the Hansard corpus data, we've got reasonably good adjusted R-squared values. Okay. So what do the models look like, or what do the individual predictors behave like? This is what is visualized here. So each of the 4 models is depicted with a different color here, and you've got the scores for the different, or the coefficients that have been calculated for the different predictors in the model. You see the value for the coefficients, you see the confidence interval. If the confidence interval overlaps with 0, then we don't have a significant effect, as is, for example, the case for token frequency in the Nuss, in the model for Nuss derivation in the Hansard corpus. So there we don't find a significant effect. But so if there is no overlap with 0, then we do have a significant effect. If the coefficient is left of 0, then we have a negative effect, negative correlation. If it's to the right of the 0, then we have a positive correlation. Okay, so what do we find? First of all, the strongest effect is clearly type frequency, and it's a positive effect as predicted. So if individuals have high type frequencies for a particular pattern, they will also tend to use the pattern more productively. And that's exactly as predicted by the literature. In contrast, we also find the predicted negative effect for token frequency, albeit that we only find it in the New York Times data. We don't find it in the Hansard corpus, but at least it's there as predicted. It's not as strong as the as the effect of type frequency, but it is there. So the data behave as expected. Next, we find some register variation. I'm not going to go into this, but or I'm not going to go into this in any great detail, but in general, we find that news, which is the reference value here, so it's not depicted in the graph. News is a little bit more conservative, so productivity tends to be lower for the news desk and higher for the other desks, with some significant effects there. Yeah, I don't well, I don't know if this is interesting per se, but at least it's good to know that it's been controlled for. So that means that yeah, we're a little bit more assured that whatever else we're describing here is not distorted by a hidden register effect. Okay. Then not what didn't survive the variable selection procedure is the variable lexical diversity, so that had no effect, perhaps surprisingly. And then we come to the two, I think, most interesting effects. First of all, there is general productivity. General productivity survived the variable selection procedure. It's there as a significant effect with other effects or other factors controlled for. So it really looks like people who score high on productivity for one derivational pattern tend to score high on productivity for the other. That effect is still there, even when the other effects are controlled for. And then finally, there is also an interaction effect between token frequency and type frequency, and that's unexpected. And it's also something that I'll have to turn to in a little more detail. So in what follows, I'll look at first this what this effect of general productivity tells us, and second, what this interaction between type and token frequency might be all about. Okay. Yeah, so this summarizes what I've just said. So let's have a look at general productivity. Individuals indeed vary in how readily they produce new morphological types. And that's regardless of known determinants of productivity, such as type and token frequency, or of lexical diversity, or of diatypic variation. So this is an effect that comes on top of all these things. And yeah, perhaps we've stumbled here onto irreducibly individual variation. So this is variation that can't be explained away by the predictors of productivity that we currently know. And it's interesting to speculate about this. So there is a word of warning here. So we're talking about just two patterns here. So I've called this general productivity, but yeah, really we're just talking about two patterns, and there are pretty similar patterns. They are both highly productive, so they're both at the extreme end of productivity. Lee and Nuss derivation. They're both Germanic. They both involve Germanic suffixes. Maybe that plays a role. Yeah, so they have some things in common. So maybe, yeah, if we were to include more patterns, maybe we wouldn't get as clear a picture, right? Maybe, but still, for these two patterns, the effect is there. So what sort of speaker property are we touching on here? So this is something that's interesting to speculate about. Does this have to do with does this correlate with other features of people's linguistic behavior? Does this correlate with more general cognitive features? Maybe does it correlate with social characteristics? So this really looks like something that should be explored further. And yeah, we can conclude that we've found something that is really uniquely individual, it seems. Okay. On to the interaction of type and token frequency. So what is this? So first, to understand what might be going on, it's good to inspect this interaction effect a little bit more closely. So what you see plotted here is the effect of token frequency on productivity. And in blue, we see the effect of token frequency on productivity when type frequency is average. And here we see the expected negative, slightly negative effect. When type frequency is low, you get what you see in the orange line. So this is the effect of token frequency on productivity when type frequency is one standard deviation below average. So this is what you get when type frequency is low, and here we see a very strong negative effect. But when type frequency is high, surprisingly, token frequency actually has a positive effect. So here we find something that's unexpected and that had not been predicted by the literature. Okay, we can also look at this from the perspective of type frequency and create the same and use the same kind of graph. So what you see here is the effect of type frequency on productivity when token frequency is average, when it's low or when it's high. And what we see then is that the effect of type frequency is boosted when token frequency is high, but softened when token frequency is low. So we get a steeper curve with high token frequencies, but a kind of less steep curve when token frequency is low. Okay. So this can be summarized as follows. So productivity is low when type frequency is low and token frequency is high, and that's as predicted by the literature. Productivity is high when type frequency is high and token frequency is low. Again, that is as predicted by the literature, but productivity is highest when type frequency and token frequency are both high, and that is not expected or not predicted by the literature. It's not predicted, but I do think it makes sense. We can actually think of token frequency as both a conservative and a creative force. So at type level, token frequency is, as the literature says, a conservative force. So high token frequency leads to automation, holistic storage, loss of analyzability, and a pattern with many high frequency types will have few highly analyzable types, therefore will have poorer schema representation and will have low productivity as a result. So that is the effect that the literature describes. And here, token frequency is essentially a conservative force. It keeps you from producing or from producing new things. It keeps speakers from behaving innovatively. However, token frequency also works at the schema level. And one thing that token frequency does, of course, it leads to holistic storage, to automation, but it also leads to ease of access and increased chances of selection in usage. And at schema level, increased chances of selection, of course, boils down to higher productivity, because it means that whenever the opportunity arises, the chances of a new coinage being produced are increased. If a schema is highly accessible, then people will use it whenever there is an opportunity to do so, and so they will also automatically use it more productively. Now, that idea links to some previous research that I've done. For example, one thing I found is that in a previous study is that Lie adverbs are produced with higher type frequency when they have been primed by a previous Lie adverb. So in this particular study, I took data from the conversational spoken BNC and took out or selected all the Lie adverbs and divided them into groups depending on how distant they were from the previous Lie adverb. And now it's found that in the group of Lie adverbs that is most distant from the previous Lie adverb, type frequencies are lower than in the groups that are nearer to the previous Lie adverb. So it suggests that when people have been primed for Lie adverb formation, because they have recently been primed for Lie adverb formation, they can use Lie adverb formation a little bit more productively again. Okay, so in this case, of course, I've used type frequency as a measure of productivity, which does not entirely is not entirely consistent with what I've done in the main case study I've been discussing here, but it does point in the same direction. Another indication here is some work on the word key, which in recent history changed from a noun into an adjective. So the change has already been well described. For instance, initially in work by David Dennison, and then later on also in work by myself. Proceeds in a number of steps. So you start from just the noun, the key to healthy public finances, for instance. Then you get key initial compounds, and key initial compounds can be thought of as noun-noun sequences. So they're it's a perfectly plausible analysis. But of course, they provide a basis for let's say reanalysis, where the initial element of the compound key is reanalyzed as an adjective. So noun sequences like key question can be reinterpreted as an adjective noun sequence. And once that happens, you start getting a number of new things. So key will undergo debonding, which means that it starts occurring in contexts that are primarily associated with adjectives. So nouns are not completely impossible here, but the dominant form attested here would be an adjective, as in this figure is a key one in the argument, or the key environmental impacts. Right, so here, this is what with Christel van Goethem I have called debonding. And then you get uses of key where key is definitely an adjective. First, attributive uses, which makes sense because that's the locus of reanalysis, so as in some key and important issues. And then finally also key in predicative contexts, as one seemed to be key. Okay, now what I found, again, looking at individual variation, as I've done in the case study on Lie and Nuss derivation, is that speakers are more likely to use key innovatively as an adjective, so that's steps 2, 3, and 4, if they already use it frequently as a noun pre-modifier. That's step 1. So if people are advanced on step 1, they're more likely to also advance on steps 2, 3, and 4. And again, you can see this from parliamentary data. So here you have a lot of data points for different MPs, and on the x-axis you have the degree to which they have advanced on step 1, so that's the normalized frequency for key compounds, and on the vertical axis you have their degree of advancement on the innovative uses, so the adjectival uses. And what we see is that well, basically you need to have the compound uses in order to adopt the innovative adjectival uses. So what you do not get is people using innovative adjectival key if they're not using the compound key. And of course, the more advanced people are on their use of key compounds, the more likely they become to use the adjectival uses as well. That brings me to a view of language change where a dominant factor in language change is what I would like to call availability, and I think it's an often neglected element in language change. So innovation in language and language change is triggered by availability. Speakers have to be thought of as constantly looking for coding solutions to coding problems, and as they do so, the solutions they will stumble on will typically be the solutions that are available to them. But what is available to them varies, both on the short term and in the long run. So on the short term, because of priming effects, priming will make specific resources more or less available than others and will steer people towards particular choices. But also on the longer term, because of entrenchment effects, which vary across individuals, but also vary over time due to language change. So, for instance, as key compounds become more entrenched, it becomes more likely that people will stumble onto key as a possible coding solution also in adjectival contexts, and as a result will use key innovatively. And that's what happens. So if for some reason at some point the most available resource to a speaker is not the canonical resource, then the speaker will produce an outcome that is innovative. And I think availability is closely linked. The factors that determine availability are the factors that determine the innovations that happen at a particular stage in language. So these two things are intimately connected. Now, to wrap up, I'd like to return to the questions that I had asked at the beginning of this presentation, and that's first of all, how extensive and how deep is individual variation? Well, I did find some irreducibly individual variation. It doesn't lead to individuals being mutually unintelligible as far as we can tell, or it doesn't lead to very obvious differences between individuals, but there is some irreducibly individual variation that's there. So that does seem to be relatively deep. Second question, is aggregate data still a reliable source of evidence? Well, despite the fact that there seems to be some degree of irreducibly individual variation, by and large, the results of my study presented here align with the aggregate-based findings. So I didn't completely reject established theory, not at all. By and large, I get very similar results that make sense within the theoretical framework that's been developed based on aggregate data. So should we chuck out the aggregate data right now or based on this particular case study? I would say no. On top of that, what the case study that I've presented here has also shown is that there are many, many practical challenges to putting individual data to use. So there's, I mean, you're perfectly justified in raising or frowning your eyebrows in the course of this presentation, because there are many decisions that have to be made, and some of those are at least somewhat problematic. There is the register variation. There is the lack of spontaneous individual data, or at least available in large amounts. There is the problem with polluted data, so third-party intervention, and so on. The problems with transmission. Yeah. So quite a few problems here that will say, okay, this individual data, it's interesting, but perhaps it's not yet the ideal source of data to do linguistics on. Will linguistic theory need refining or revising? Well, judging by this case study, I would say there is some fine-tuning. There was this unexpected interaction effect between type frequency and token frequency. Post hoc, it could be fitted into the existing theoretical framework. It makes sense within that framework. So that's what I would call fine-tuning rather than wholesale revision. But I would say that large corpora representing individual usage do offer a new opportunity for linguistic theorizing, and they raise new questions have come out of this, and also new opportunities and new possibilities for testing established theories have come out of this. So it's certainly an avenue that's worth exploring, and we can ask ourselves what's going to come out of this. Is this the beginning of a big change in linguistics, or is this maybe just a temporary fashionable thing to do? We'll see. The future will tell. So we've opened the box. A wisp of smoke has come out. Let's see what comes out next. I thank you for your attention.